Okay, thank you. Good afternoon to everyone. I'm glad to welcome you to the initial seminar of the CERIAS seminar for this semester. So this semester we are very lucky to start with a really outstanding speaker. So we are lucky that Professor Steve Elliott is presenting the first seminar. Professor Elliott is Professor of Technology, Leadership and Innovation and the school and the College of Technology at Purdue University. He has done very important work in the area of biometrics, and he directs the biometric lab, which has a lot of very interesting projects and a lot of students. So I leave the floor to Professor Elliott. Thank you, Steve.
Thank you. Good afternoon. And today I'm going to be chatting to you about biometrics, giving you a brief introduction to the field, and going to concentrate a little bit on the issue of error and understanding that. So my agenda is we're going to start off, I'm going to make the assumption that you might not know everything about biometrics, so a little bit about concepts of identification and maybe 3 or 4 slides on History 101. And then go into some performance definitions, take a look at what we coin HBSI, which is human biometric sensor interaction, then take a look at a case study, and then wrap it up with some conclusions there. So I assume that most of you are CERIAS students. You see a couple of faces that I recognize, so hello everyone. By default of recognizing people in the room, you all have different backgrounds, and one of the nice things about biometrics is that it is interdisciplinary by nature. So there is obviously a core set of underlying algorithms that do image processing in biometrics, but there are also some areas where people can get involved with from the aspects of design, privacy, human behavior, engineering, security, and biology, obviously. So hopefully there'll be something in here for everybody with respect to your own flavors of discipline as well. And if I've missed anyone's field off, let me know. I'll append it to the slides that I'll post. The challenge that we get with biometrics, and this is a good thing and a bad thing, right? But a good thing with biometrics is that it's becoming pervasive. And for those of you that traveled here from a foreign country, you probably went through US Visit. For those of you that have biometrics on your laptop, you interact with it there. So you've got a big, large-scale government program for access control into the country, immigration control, and you got single sign-on. And you have everything in the middle, which makes my job really, really interesting because I can kind of pick and choose some of the things that I want to look at in terms of research. But it means that we're always being challenged by different sets of environments, from a well-habituated user that signs on only their machines, very used to their machine, akin to you being used to your keyboard and not being used to someone else's laptop keyboard, all the way through to the first-time user that's just come off a plane after a 5, 6, 10-hour plane ride. So that's the nice thing about biometrics. That's also the challenge, because with everything that you have with biometrics, you're involving individuals that are well-trained, individuals that have never seen equipment before and have never been involved in the scenario or the environment that we're placing them in. And that brings with it a lot of challenges, and that's some of the challenges that I'm going to talk to you about today, because when you're deploying systems, you'll get a set level of performance, and you can tweak that performance only so much. And that performance you can tweak algorithmically or from the system, but ultimately you're relying on your user, the people like you and I that will be interacting with the system, and how do you get them to perform appropriately in the system in order to maximize your performance. So that's kind of what we're going to be talking about today. In order to do that, we need to take a look at the concepts of identification. Now, this is a long quote, but it's from Clark in 1996. He says, human identity is a delicate notion which requires consideration at levels of philosophy and psychology. So we'll take a look at the next sentence, which is a little bit easier, which is human identification, on the other hand, is a practical matter. And how we do that is interesting. He outlines a list of ways to identify an individual, and we use that every time. So some of you I haven't seen before, and others of you I have, and others of you I haven't seen for quite a while. So there are different things that I have to think about when I'm dealing with this. First of all is your appearance. So I've got a list of appearances in my head. And one of those is, okay, I look around the room, do I recognize anybody? Yes. Have they changed? No, not much. And so I go back into my brain, assuming that's a good database to go to, pull up their name if I can remember it, and say, okay, I validate that individual. I might not remember their name, but I might remember something about them, how they interacted with people, or their nickname. I might be able to say, oh, I know his nickname, I can't remember what it is. I can't remember his real name. Or I remember what people called him or her, and it's not their real name, or something like that. And you've already probably been in situations where you remember someone, or you do a double take in a different location. You know, I kind of remember who they are. When you get down to some fundamentals, we're probably interested in these four ones here. What a person knows, knowledge, typically a password or something like that. What a person has, so a token, you will have some identification on you. Or what a person does, or what a person is. And so in this case, they're called biodynamics or natural physiography, but essentially that's biometrics. And so that's what I'm interested in at the moment, not necessarily the tokens or the knowledge, but the bits about you, what you do, how you behave in the person. So that's the two items that are of interest, and we'll carry those forward throughout this lecture. So here's the definition. Now the definition is fairly stable. Biometrics in itself has been around a while. I'll come to that in the History 101 slides. But you can see it's automated methods of verifying or recognizing the identity of a living person based upon some physiological or behavioral characteristics. That's kind of it in a nutshell. There's some caveats here. Automated, so I can't go back and think about it later on. When I'm at the border, you want to get through. It's always like the last hurdle or the last mile, right? You've made it all this way, you've gone on the plane, you've done your plane ride, and you want to get processed as quickly as possible. And so automated is the essential part of it. We're not dealing in the realm of forensics. So you can use image processing, biometrics that use image processing can be used for forensics, for people that are dead. But we're interested in not the biometrics, so to speak, of dental records, right? You'd use the same thing, but we would use the biometric bit as the living bit. So that's what we're interested in there. So the automated and the person. We have done some biometrics on animals in the lab, but the definition concentrates solely around people. So there are challenges and opportunities within biometrics, and many times when you take a look at challenges and opportunities, sometimes you're overtly critical about your own technology and fairly maybe naive about other people's technology, right? Because that may not be your domain. So apologies to the cards and the passwords folks in the room who might have already done the tree diagram to prove me wrong. But hold on a minute. First of all, there is no best biometric. There is no best token. There's no best password. It's a function of a lot of things. And so you could have a 2-digit password or a 50-digit password. All of those will come with their challenges, right? So you have a very strong biometric. You can have multi-biometrics. And so you really have to treat it as a system in itself. So you do have some challenges with passwords and tokens. They can be stolen. They can be shared. And they can be lost. And biometrics, to some extent, may have certain issues as well. You might be able to spoof a biometric, for example. So I'm not saying that biometrics don't have any weaknesses, but they all have different challenges and different opportunities within the market space. So if you read the literature, and it's a pro-literature of biometrics, you'll see that biometrics are more difficult to share, copy, or transfer. And that's a really broad statement. Because if I have a really good secure card, then maybe biometrics may not be as strong as that card with PKI on it and whatnot. So be very careful when I sit up here and I provide some comparisons. But there are 3 different ways. They all have their strengths and weaknesses. In terms of classifications, there are 2 main types of biometrics that we're interested in, physical and behavioral. And so with the physical side, fingerprint and iris, something that I can actually measure from my body. And the other side, the behavioral side, is signature, keystroke dynamics, how I type, how I sign. And in some cases, I sign differently depending on the level of ceremony. Anyone that has bought a car or bought a house knows that you're going to sign properly. Anyone that's, for the purposes of the video, on Harry's is a local bar in town. Anyone that's been to Harry's at 2 o'clock may have a different concept of signing. So that's a challenge that you have if you came across and said, but that wasn't me at 2 a.m. And so there are different challenges that we have with these behavioral ones. Nonetheless, from a research perspective, really kind of interesting challenges. So never, a challenge can therefore be an opportunity sometimes. This is a non-exhaustive list of modalities. Fingerprint, face, iris are popular ones. Coming up with vascular palm, hand geometry, of course, for access control, voice signature, and then you've got retina and gait. And multimodal is where one isn't as good as another, and you could combine the two. So I have really poor image quality on my fingers. Some of you may have really good fingers. So maybe we use the face. So maybe we don't use the face for you guys. We use the face for me because my fingerprints are weak. So there is a trade-off as well. And multimodal is kind of an interesting area to work in as well. Let's take a quick step back at history, give you a perspective of where we've come from, because that will also indicate some of the challenges that we have in directing where we may want to go. And if you don't understand history, then you have a tendency to repeat yourself. So biometrics in its concept has been around for absolute centuries. You've got legal documents and government documents being traced back to well before Christ in terms of date lines. Traders in Egypt, child identification in palms and footprints. You'll see on cave walls this activity. Now, it's not biometrics in the true sense of the word, but it is some form of identity, whether it is putting your thumb in wax and sealing that scroll with wax. There's some historical identity associated with that. But in the 1800s, around 1823 to 1858, that's a pretty small slide, I appreciate, you see some evidence of people thinking about identifying individuals, and typically through body measurement. Right? So there's this concept that people are all different. Maybe we can start to measure that difference. So in the 1880s, you get Folds, Galton, and Henry. These are classic people involved in the initial efforts in identifying individual. And if you take a look at the history, kind of a side note on history, is around that time too, there's a lot of people that are looking into statistics and statistical methodologies. And I got some pretty interesting slides that I won't show in this about how some of these people actually meet. And it's kind of cool just to look at what's going on in the late 1800s with respect to that. 1909 in the UK, 1911 in the US is when we start looking at fingerprints in courtrooms. You have the wars going on, so you don't see a lot of activity post the Second World War until around the 1960s. But at the same time, post-1960s, you've got an abundant growth in computing power and the thought processes. So there are some patents around 1923, 1940s, 1950s that suggest, for example, iris recognition, but there isn't the computational power to kind of bring this to forward. 1970s, 1990s, when the government gets involved through NIST, which is the National Institute of Standards and Technology, and they start running tests, DoD, face recognition, ferret, and the like. So if you go on their website, they have a number of different tests that want to establish whether particular algorithms, so there's kind of algorithmic tests. And you take there's a group in Italy that do FVC competitions, fingerprint verification competitions, and they've been doing that since 2000, where academics and companies can submit their algorithms on a set of data and you get performance reports. So you get the initial kind of birth of a new science that's fairly new, underpinned by a lot of history. And so obviously these days with computational power, advances in sensors and sensor costs coming down, you can definitely see a growth in that. Our first iris camera that we bought was nearly $10,000. You can buy that for about $1,000 now. So you can definitely see the price tag has come down, and that's been helped a lot by the stuff that's been going on in history. You see in 2000s, further development in iris. You've got some presidential directives coming. You've got DoD. Then you've got these implementations, U.S. Visit in the U.S., which is border security and immigration. You have iris recognition at Dubai and the United Arab Emirates. You have some programs coming up in the UK. And so as this grows, you get the development of standards that we've been working on in the lab. And so now the market is fairly mature in some cases, and so you now start to see some of these activities coming down onto your personal computers. I don't know how many people in the room have a fingerprint sensor or a swipe sensor on their laptop, but they're definitely available. Or you may have photographic or face recognition on a laptop. You see that Apple is looking at doing face recognition on cell phones. And so a lot of this development is not necessarily new, but it's coming down to be price point accessible. So that gives you a bit of history, and this provides you with some evidence about the model. Now, the really nice thing about biometrics is typically it all follows the same model, regardless of modality, which is kind of nice in some respects. So if you take a look at that, there are data capture, data storage, signal processing, matching, and decision silos in that chart. And you can see that there are two different lines that go through that graph there, or that figure. The red dotted line is the enrollment line, and the blue line is verification or identification or recognition line. Before we can really do anything with you, we have to enroll you. And so enrollment sometimes provides its own challenges. The challenges are that if I'm going to enroll you into the system, this is typically the first time you've played with the system or interacted with it, and therefore you might not be that good at using it. It takes a little bit of time to use some of these devices, at least get used to them. So that's one of the challenges you see with large-scale deployments, is when do you enroll someone, and then when will they use it again? So I'm pretty fortunate. I travel a lot. I'm always going through US Visit. I probably went through it, I don't know, 15, 20 times last year. I probably did 20 international flights maybe. And so I'm using that every 3 to 4 weeks. I think I'm okay at it. I get through in the allotted time. I haven't been chucked out once yet in terms of not using the sensor properly. But if my parents were using a biometric system, they travel internationally maybe once or twice a year. So you have to make sure that the system is easy enough for someone to remember how to use it in order for us to get good quality images out of them later on. And so the enrollment sometimes requires you to have a little bit of training. There's always a cost issue associated with training. The longer I train you, the more it's going to cost in terms of time and resources. So that's another area of interest that we're doing in the lab, is looking at training, and I'll come to those slides later on. But this is the general biometric model in terms of the process of biometrics. We concentrate mainly in our research in the first silo, and then maybe the signal processing area. The first one is really key, in my opinion, because if you acquire a poor quality image, everything downstream for that is going to be problematic. If you acquire a good quality image, then we should be good. The challenge is, how do I collect good quality images, maybe when the person themselves, through no fault of their own, can't provide them to me, especially if we've got a large scale where I can't really exclude people from the biometric system as itself. So not everyone comes to the table with 100% image quality. Everyone changes over a period of time. It introduces some challenges into the system. So biometric enrollment and recognition, I kind of went through there. Biometric data is acquired from the individual and stored somewhere, wherever that is. It could be in a centralized system. It could be on a smart card. So don't necessarily do the dotted line into the cloud or into some big government system. It could also be stored on a smart card, and you can walk around with it. All three of those have challenges in the computer security realm. It's kind of outside of the talk, but probably someone else down in this seminar will talk about security issues. And that's something you need to think about, though. That'll also impact how you match as well. Recognition is grabbing that image back from wherever you have stored it and reacquiring another sample from the subject and simply doing a match and figure out whether those matches are from the same person or not. And herein lies some challenges. I can alter the level of security depending on my application, which sometimes can be problematic and advantageous as well. So let me give you an example. If I'm a security manager for a bank and I have an ATM kiosk, for example, where do I want my security level to lie? At the low end, low security, or at the high end, high security? It's protecting your money. It's your account. What do you want, high security or low security? High. Good. All right. Hopefully, right? Unless you got no money in there and it doesn't matter. All right. So at the beginning of the month, high security, definitely for sure. All right. But if you have high security, there could be an opportunity where I present my fingerprint, for example, and it rejects me because I didn't put it in appropriately. I might have rotated it. I might have deformed my finger sufficiently when I press down, and I get rejected. Now, if I get rejected, who am I going to blame? Assuming I never blame myself, right? I'm going to blame the sensor. I'm going to blame the bank. I'm going to be upset with it. And someone's behind me in the line invariably when this goes on. And I say, oh, I'm not going to use that biometric again. I go complain to the bank. The bank says, well, we've got it high security because we want to protect your account. And so there is a trade-off between usability and security. If you want to get in every time, then I lower that threshold, and then you can get in every time, but you have the chance that someone else may get in instead of you. In which case you'll get upset with the bank again because you'll say, well, someone else got back into my account and they took all my money. And the bank will say, well, didn't you want the security level reduced? And so from a security professional, this is quite a complex scenario to deal with because everybody will have different kind of potential thresholds that they operate at. And so how do we deal with this? And one of the ways is to get the user to interact properly with the device, and we'll show you how we get that on. So here's the model. We're interested specifically in this conversation with data capture because it impacts our ability to segment the image, to take a look at feature extraction and again, quality control. Because you see that arrow there between quality control and the sensor. It says reacquire. If I have a reacquisition, that's going to cost me probably a bit of goodwill or faith in terms of the customer that's trying to gain access to the device. It's going to cost me some time because I have to reacquire the image. It's going to cost me money because I've got two people sitting there, probably one trying to get the person to use the system and the bank person as well. So that's costly, and I don't want to go ahead and put a lousy image into my system if I can help it. So these are the challenges that we have. This is a performance set of curves. This comes out of Tony Mansfield's National Product Testing. This is a multimodal report. You can see it's dated 2001, but the concept still holds. You can see on this curve here various different levels of performance at various different thresholds and operating levels of false matches and false non-matches. And so these are the charts that we deal with. So at different operating points on this graph, there are different modalities perform better and different submodalities, as you can see here, FP optical and FP chip, 2 and FP chip, fingerprint, chips, and opticals. So different sensors, different sensing technology behaves differently on the same crew of people at different operating levels. So that's why we'll steadfastly refuse to answer the question, which biometric is best, unless you come to me with a set of characteristics of your operating environment. Because if you want to let anybody in, then that graph will tell you which one's best. And if you want to let nobody in, that graph will tell you which one's best. But you have to come to me with at least a set of operating parameters. And that's what these curves enable us to do. But what they don't do is they don't tell us the individual contribution to that error. So I can tell that a particular biometric system operates at this level, at that threshold, but I can't tell you what happens when I remove one person from that. I can rerun the data, but I can't identify individually really what's going on. And so we've been working a lot in the lab about trying to identify the contribution of error by individuals. Right? And take one person out. What does that do to the rest of my curve? And how does that impact? And is there anything I can do with that poor performing individual, or are they just heads up poor performing? So when I enrolled in Global Entry for the fast passage through immigration that the US government's running at the moment, I use my left hand, I don't use my right hand because my right hand has poor image quality. My left hand is a little bit better, so I use my left hand every time. So the contribution of my error can be brought out a little bit more. So we want to look at how people contribute to error, not necessarily the global effects. So when we do that, we look at the data capture area, and that involves how people present their biometric to the sensor. And by presenting, I don't necessarily mean, placing the hand flat on a hand geometry machine or swiping, although that is encompassing that. But it's whether they look at the camera or not. And so some research that's being done is how do you get someone to look at a camera? Do you have a commercial or a TV playing, or soccer or football or whatever it is, or something to get someone's attention so they look up there and then you can grab their image instead of just looking down, kind of like nodding their head and kind of, how you are when you get off a plane, you're kind of tired, you slouch, your bag's on there, and you kind of follow the crowd. How do I get someone to look at the camera is also part of this, although they're not necessarily interacting with the camera per se. So we have this conceptual model that involves the human, the sensor, and the biometric system. The human from this aspect is typically the subject of interest, and the subject of interest typically is the person giving the biometric, although this year we're doing a lot of work in the operator, because the operator also contributes to the error. If someone is chatting with you about some other activity, say the football scores, when I used to come through and talk to an immigration officer, they say, what do you do? I do biometrics. And then we get talking about the device. Or they say, where do you work? I work at Purdue, and he's a Purdue alum, or has a relative that works for Purdue. So the conversation with me will be very different maybe than the person that's behind me. And so maybe that operator may make an error on me because they're paying attention more to the conversation that they're having and may double click or may miss something. So we're also doing some work on looking at operator error and how the GUI and the like contributes to the error of collecting the data, not necessarily the data itself. If you're interested, there is a lot of papers, but Hinkling is the best paper that has a list of contributing issues to error. And error is key because it's either me with poor image quality that contribute an error, or actually my behavior, or actually the operator keying me in as Bill instead of Steve. I mean, it's essentially an error in the system. So we look at usability. So who are our users? The set of everybody is quite a challenge. All right. What do they need to do to present the biometrics successfully to the system? Can they do it consistently? What device is being used? Does that device change? And in what environment are we looking at? Just to give you some examples here, there's some inconsistent and dry fingerprint, good consistency, young and old. All right, we've been showing this slide for quite a while. You still get old, slide's still valid. No matter the amount of moisturizer you use, you are going to age, right? And so your fingerprints will degrade over time, and it's an area of interest because that's something that's a challenge. If you take a look at your passport photographs that you have, something's changed over a period of time. You might have gained weight, you might have lost weight, you might have lost some hair, you might have grown a beard, you might have done all of the above, you might have done none of the above, right? You could be stable. That'd be great, right? But some stuff would have changed, and so if I enroll, how long is my passport valid for? Am I going to change in that period of time? Okay. So there's the challenge that I have. If I use the passport photograph for whatever it is as the enrollment, how do I update that? Should I update it? And stuff like that. So lighting, environmental conditions. I might be wearing glasses, might be wearing a hat. I might want to do identification of you on a building site for access control. That photograph will be different than your ID photograph because you typically in that environment don't take an ID photograph with a yellow hat on in your safety specs. So again, the algorithm has to choose, and we sometimes make it hard on ourselves. Cultural influences. Okay, I might not be able to grab the biometric that I want because I might not be able to through cultural or religious beliefs. Occupational issues. So manual labor. People that lay brick, for example, may wear their fingerprints down a little bit better or quicker than people that type. Working with chemicals, abrasive materials, behavioral factors, I'm used to it. I use it every day. I see it once a year. I see it once a month. I'm not as used to it. So biometrics and usability definitely provide us with some challenges, good challenges. Nevertheless, we have variability of the human, we have placement and orientation issues, we have physical factors, we have environmental factors, design issues, and the like. Which is really cool because, as I showed on the first couple of slides, I haven't said anything about image processing yet. That's all an IE issue, right? Or lots of it is an IE issue. It's also a psych issue, right, in psychology. So the nice thing about biometrics in some cases, if you take a look at the faculty profile of CERIAS, you can see every faculty profile in CERIAS from psych, IE, all the way through fits quite nicely into the profile of biometrics as well. So that's kind of the cool thing about doing it, because I can interact with more than just the one group of researchers. We're interested in repeatability. Sometimes we change on purpose. I might get a new haircut, I might get a new hairstyle, I might grow a beard, like I said. Sometimes, through no intention of myself, something may happen to me. And then sometimes I have to specifically interact with a device that I might not be used to do. So when I go through Heathrow Airport, I'll show you a slide in a minute. When I go through Heathrow Airport, I use the iris lane. It avoids the immigration lane that I have to go through. And I take my glasses off. And that changes the game. I take my glasses off. I have to look at the device. I'm not that poorly off in the sight department yet, but I still can't see most of you, as you just one big blur. So I now have to interact with the camera that may or may not be interacting properly with. But if I put my glasses back on and the lighting here is an issue, then the light might come back down and interact with the ability for the camera to see my eyes. So you've got some challenges there. How do we provide best practice to people coming through? How do we do the signage appropriately? And how do you provide the signage to a group of people that encompasses the set of everybody? Because one sign for one person may not read the same sign as another person. If you travel internationally, there's some set of signs that are common, and then in some countries those signs are very different. All right. So how do I tell people to put their glasses on and glasses off when English may not be their first language? So temprint on a fingerprint sensor. How do I space my fingers? How do I deal with that? How do I interact with it? How do I enter the sensor? All of these are issues. This is a hand geometry issue. Hand geometry machines change design over a period of time. That's an access control. I place my hand, interweave my fingers with those pins. You see the pin layout is stayed the same, but the device looks different. So people may go, oh, it's a different device, doesn't look the same. Sometimes you may get missing digits, a small hand, a normal user, whatever that is, a normal size hand, and then you get a really big hand. So our hands are fairly different as well. And so that's of interest. Fingerprint design. These are different designs. The one in A is a laptop. Now, laptop fingerprint sensors, you got to love them from a research point of view. They stick them sometimes in not the best place, right? I remember I had a Toshiba tablet that works really well when you've got it in tablet mode. I can swipe my finger down like this and don't have to chalk my hand across the screen and get fingerprints all over it. But when it's in typing mode, it's like that. And now I have to go like that and I give up. I don't bother, right? And you ask why'd you put it there, and that's where the real estate, because all of the other stuff inside the machine, even though the fingerprint sensor has a fairly low profile, they place it there. So you can see in A, that's fine for a right-handed person, but a left-handed person, what happens? The fingers interact with the mouse mat. So off shoots the mouse, all right, and now you can't do what you need to do. So, some challenges there. Not necessarily they didn't think about it, but maybe they did and made the call. You can see in B there's a height sensor's different. You can see in C that they actually have a locator for the fingerprint, so you can't overshoot your finger. Different interaction environments. When I use the kiosk at US Visit, you see that the interaction environment there is I'm on my own. I have no guidance. I have a screen that shows me whether I'm good image quality, bad image quality. My hand lights up, my fingers light up, and then they get squares over them. And it's a red square, yellow square, green square. Green's good. Yellow is you need to work on it. And there's a countdown clock that says you better work on it fairly quickly. Otherwise, you join the line or you go to the front of the line. So that's the system there. When I go through the line, if I wasn't in global entry, for example, and I just went through the regular US visit lane, then the immigration officer has to provide me with the guidance because I don't get a screen. Just place your finger there, whatever, place your hand. Outdoor, indoor, that's another environment as well. Training, how do I train? We've done some research on this, looking at how people learn. You learn differently. You may be a visual or a verbal learner. You may read or you may want to watch a video. In an immigration line or in an instruction line, how do I best convey what I'm trying to get you to do in the period of time that you're trying to do it? All right? And I may have half an hour in an international flight when everyone arrives at the same time. Say at Dulles, I may have 2 hours to get the message across. But I've been in Dulles when there's been no one in that immigration hall, and I made it all the way through, and they've been waiting for me. Therefore, you have no time whatsoever to give me any instructions because I don't want to hang around just in case that plane load of people is nanoseconds behind me and I want to keep moving. So that's a challenge, right? So it's inconsistent in terms of my training. This is an example of US visit, and you can see the interaction there. They also have camera take face as well. Those are the 3 different cameras in the iris implementation, different heights. I tend to use the middle one, if that gives you a guide. I'm 5'11". And so we get to individual errors I've been talking about. Individuals will contribute different errors to these sensors here. I want to know who they are, what they're doing, and how I can fix it. And so that's how we get to the HBSI model, this model that we talked about. How are the biometric features affected by the environment? We do some skin analysis in the lab. So we'd like to know how moisture elasticity and oiliness of your skin, for example, impacts the sensor. It does. How much noise does the environment add to the signal? So we've got bright lights, darkness, and all of that stuff. And then how do physical and behavioral factors from the user affect the algorithm as well. Let's give you a quick case study here in the time that we have remaining. So if you take a look at a fingerprint sensor, that scenario at US Visit where you place your hand in, you've got 3 things that you do. You place your hand on the sensor, you have your hand on the sensor, then you take your hand off the sensor. Simple, right? Oh, you can do so many things on that journey from placing it on to taking it off, you wouldn't believe. So that's of interest to us in the HBSI model. So we videotape the interactions of the subjects, and we sit there and watch and code and identify the various aspects of what people can do to then see whether we can kind of intervene in this process. So if you place your hand onto the sensor, there are 2 different ways of doing it. You can either place your hand flat like that, so all your fingers land at the same time, or you can kind of do a piano movement. And so we see a lot of people go like that. Don't know why, just some people do that. So that to us is interesting because if you go like that, then the force is laid down at the same time, and if you go like that, then there's some differences there. And so what happens to the level of force on the pinky versus the index finger? No force or no pressure is a light print. Too much pressure is a too dark a print. Going to go to 3 bears rule here. So we like to have a moderation of pressure, I suppose. We have some values. We've done some work on this in order to optimize the print. So other things that people do with this is they do tips. So just the top of the fingers here. So that's something that's interesting. Fingers bent up where they will put their hand up and then for some, I can't do it, but their fingertips here will go up. So that's kind of interesting. Some people do nothing that we can't, no obvious way of doing it, just put it down and go. And then some people pivot. So there's some modifiers. So you may pivot with your hand and everything else like that. So that's kind of interesting. So now we're drawing out a little bit more information about how the subject interacts with the device, not just that's the performance of the device. Now if we can go back and see, well, the people that just put tips have less area of the finger on the sensor that we can capture as opposed to people that just do flats. Or if you do tips and flats because you're completely inconsistent, then that could be of interest as well when it comes down to looking at performance. So when we take a look at how subjects place hand, we have no movement. So the hand is on the sensor, And they don't do anything. It's just they just keep it there, which is good. And that's it. Some people look at this. If we show them the image, they'll move their hand around because they'll assume with no guidance that the initial image wasn't good enough. So we present them sometimes with live scan images so they can see the rotation of their hand. Sometimes we turn it off. And then some people shake. So through no fault of their own, they will shake when they've got their hand on the sensor. All right? And that is not necessarily related to any MSDs. And then sometimes people think, I'm already good, it's got my image, and it hasn't, and so they'll lift off prematurely. And if they lift off prematurely, then I kind of get a ghosting of the image, or it will capture and then it disappears, so it's not as good as if they held on. So you've got those basic coding efforts, and so what we then do is we then go back and code our videos according to those characteristics, and we come up with some results. How do I stop someone from doing a piano? How do I stop someone from rotating their hand? How do I make them not shake if the shake is not biological, i.e. part of their makeup? And all of those factors are fairly interesting for us in terms of research, because if I'm going to go more towards an unattended environment, so a kiosk environment, I don't really want to, I'm trying to trust the user to be consistent across everybody and do the same behavior. And I'm not necessarily always going to get that. So if I can kind of create a device or a sensor or guidance that will make them as consistent as possible, then that's good for me. So we have this HBSI and error model. I'll spend a little bit of time on this because I want to explain the impact of not behaving with the device properly. If I get I get two choices. I either get an incorrect placement or a good placement. All right. And if I get an incorrect placement, there's some challenges that arise from this. The first of all is that the sensor may not detect that I've got my hand on the sensor at all. So one of the really cool things about this research is when you're videotaping, we videotape, and for fingerprint, for example, we videotape the hand, this angle, we videotape the side angle, we videotape the GUI, the sensor screen, so we see what the sensor sees, and then we videotape, so there's three angles on that. For iris, we've done the same thing, where we videotape the subject, we videotape the volume, because the camera can only see a certain amount, we videotape what the subject sees, and how they position themselves, and how they react to the guidance that the sensor will tell them. So one of the things is with a defective interaction, you put your hand on the sensor, we can see that the hand is on the sensor, and then you look at the sensor screen and it's blank. The sensor doesn't see anything. The sensor hasn't triggered, and you're kind of having your hand there thinking, well, something's got to happen, and the sensor's like, well, I'm not doing anything because I don't know anything's happening. And so that's an error. And traditionally, you wouldn't capture that error because the sensor doesn't know the error is occurring, but the video does. The other aspect of that, if you take a look at face or iris, would be you walk into the volume where the camera is meant to operate in, and the camera doesn't recognize that you've walked into the volume. And so you just stand there, and the camera's there, and nothing's happening, and there's a battle of wills between machine and human, and you sit there and go, well, something has to happen, right? And if you do this or move around or something, everyone wakes up and then it triggers off. So that's a defective interaction. What happens to that? It's a time function, right? It incurs a timeout. It's a failure to acquire. If that really is not a failure to, it is, but it isn't. I haven't acquired anything. I don't know if there's anything to acquire. So you see the nuances and the subtleties of some of these errors. But essentially, I have to go back to the beginning and resample. If you do that in a kiosk, your line grows. And therefore, I have to think, do I have to then get more kiosks to accommodate the line that's growing? Or do I deal with you in an appropriate fashion and get you to learn how to use the device, or get the sensor to do something, or build some intelligence into that? So that's one of the factors associated with that. On the other hand, it could be incorrect, and it might accept it as incorrect. Or it will accept it incorrectly as a correct sample. And so it may go into the database as I segment, say, your little finger, middle finger, ring, middle, and an index, and then I might get these two muddled up, and through a bad presentation, but the sensor will segment them, the algorithm will segment, and these will be swapped, and then they'll go into the database. And so when I come back in and I present and I do it properly, then the matches are wrong. It's all confused, and so that's going to affect my performance as well. Now, that's an example where how can we fix that? I might put my hands like that. I might have my and so therefore the algorithm may not be able to segment properly. I like to go like that, but if I go like that and I got huge hands, then I'm going to start cutting off these sides because the sensor's only this big, right? And I come to town with a bigger hand than the sensor. I've got a trade-off. So I might find that my index and my little finger have been cut off. If they cut off on the sides, then that's going to reduce maybe some minutia points that are out there that I've had. So real cool challenges and opportunities. On the flip side, we may have a correct presentation, so I'm not messing with the system. These are genuine users, so they're not messing with the system anyway. But if I presented my hand correctly as I was meant to and the sensor still didn't see it, all right, then I've got a failure to detect and a failure to process. And all of this issue here comes back to trying to get the user to perform better. All right? There is a $ associated with this model. The more errors you have, the more times you have to go through, the performance factor decreases. I got KPIs involved now, so I have to operate at a certain key performance indicator. I have to do my match in n number of seconds. I have to have a successful match in n number of seconds, right? If I don't, the line grows, and everyone doesn't like that. So you can see the performance rates online, and well, you can see the times online of how long your security line is and everything else like that. So we're doing a lot of research in this area in trying to do that. Now, this is work that's in progress. Definitely we've been working on this for maybe 7 or 8 years now. It's a long process. Because the interesting thing about this is every time someone changes a sensor, and they change sensors with all the time as technology improves, the actual interaction of that sensor sometimes will change too. So we've validated the model for fingerprint, but the model that we validated was not this model. There we go. Wasn't this model. This model has a feedback loop because the fingerprint sensors that we have in the lab now have a feedback loop in them, right? And typically when we first did this, it was a simple swipe. You didn't swipe properly, you were done. This one thinks a little bit more and then gives you a retry without kind of doing anything. So we validate against fingerprint and different sensors. We've looked and have validated against iris. We haven't published this work yet. That'll come out this semester. We published the performance rates about 2 years ago at the Biometrics Consortium conference, but we haven't done the iris performance HPSI rates yet because it's pretty challenging to look at someone and figure out everything that's going on. So there are issues relating to what the subject does. So the machine, for example, will say, open eyes wider. And what do you think you do? You go like that, but when you go like that, you straighten your back. All right? And then your posture changes. So as we're now looking at the next data collection, we're like, oh, well, now we've got to measure how the posture changes because we kind of anecdotally saw that. So you eyes wide open, you're now surprised, and now you have to look, and now everything kind of falls back into place. The camera says, I like this. You're behaving properly according to my algorithmic desires, and I will go ahead and grab that image from you. Vein we haven't looked at, palm we haven't looked at. That's what we're going to be looking at this semester. We've looked at hand geometry, and we've looked at signature. And signatures are a really interesting beast because it's different from the others because you're signing. And sometimes you decide that your signature doesn't look like your signature and you'll stop. As opposed to, you don't really look at your fingerprint and go, well, I'm not quite sure that's quite right. All right, so, but sometimes you'll stop and restart. And obviously, if you use those point of sale signature pads, you make the determination in your head maybe that those signatures don't look like the signature that you're donating and just will do anything. So that's the validation of the HPSI model. And that wraps it up in terms of my presentation today. But does anyone have any questions?
Yeah, there is a, you need to push the button. Yeah. Okay, try to speak loud. Yeah.
I was just wondering if contact lenses have any effect on the iris scan.
No. Yeah.
Okay, are there other questions? I I have a question if there are. So, Steve, you mentioned that there are some standardization bodies looking into biometric. What are they exactly standardizing?
Oh, that's a good question. In terms of, in fact, I'm going there tomorrow to a standards meeting. There are 6 working groups that are participating in what's called ISO and IEC. And they participate, they standardize everything from vocabulary. So we're a fairly young field, and so people have different vocabulary definitions for the same word, which isn't useful, because I can say X and someone will think Y and it's the same word, and that doesn't help. So that's quite a long process to define a dictionary body. And then don't forget that some other committees or standards bodies may have already standardized the words, so it goes up into a big dictionary and gets adjudicated. Data formats, so how we interoperate, for example. So if I have sensor A and sensor B and I put my fingerprint on sensor A, we need to figure out a way to make that fingerprint work on sensor B without having to enroll you on sensor B, sensor C, sensor D, sensor E, and so forth. So that's a real challenge to get interoperability of fingerprints. The other one that has been working on for quite a while, in fact that was a CERIAS project with undergrads, has been standardization of Java Bio API. It's an API for biometrics. That migrated itself all the way through, and now we've split the project into OOPL, Object-Oriented Programming Languages. We have part 1, which is the framework, part 2, which is the which is Java, and part 3, which is C#. And so that's been standardized or being processed to standardize. It'll move to the next level, hopefully, in the outcome of next week. And then we standardize how we test. So a lot of the work that we do in my lab is relating to testing. And you have to have some confidence in the test reporting. So if I say that fingerprint sensor operates at this level, and someone else goes and says it operates at a different level, then you need to understand how we did the test. So we could conform to a test methodology, so to speak, or test setups and stuff like that. Currently we're working on standardizing the environment or measuring the environment, because the environment will impact your sensors. So if I test in this light, need to measure the light. If you turn these lights off and then turn them on again, they take a little while to stabilize. So we've got some students last semester, undergrads worked on environmental stuff. And then there's the societal impacts. So signs and icons, for example, is being standardized for use at airports. We just got a standard published in access control. So how you would standardize a machine that goes on the wall for access control, and how you would determine the level of security on that machine. So plenty of stuff, 6 committees, 6 subcommittees, 6 working groups work on that.
Okay, so if there are no other questions, let's thank Professor Eller. If you are interested in details about projects and research activities, you can contact Professor Elliott. I'm
Sure.
sure he will be very glad to. Okay, so you need to sign this one.